Hello everyone, I'm Guangjun Hu. Boyu and I will present the topic of authentication in IoT and security challenges. Internet of Things is a network paradigm which is an information network formed by the physical sensors and smart devices. In a common three layers model of IoT, application and service is carried in the application layer, where the user stays. As a middleware, the network layer contains gateway and routers. At the bottom, the sensor network is in the perceptron layer. The security of IoT is different from traditional network security because IoT devices have limited battery capacity and computational power. Applying public key encryption, such as RSA for IoT, is suffering from the computational efficiency problem. In a survey of 2014, the author defined 8 security challenges in IoT. The first and the most important one is authentication. Authentication in IoT can be further divided into user authentication and device authentication, and they occur in between different layers. We will discuss them separately in this representation.
So, what is authentication in IoT? Authentication is the process of verifying the originality of the communication between users and devices. Normally, authentication is generated by the digital signature, and it is the premise of IoT, as it protects the privacy, integrity of users and devices during connections. The purpose of IoT authentication include data protection, monitoring, auditing, and secure session establishment, etc. However, because of the computational overhead, it poses huge threats to both user and device authentication. Thus, it is necessary to construct mechanisms to handle the security challenges. Moreover, the potential attacks on IoT authentication contain masquerade, dose attack, and so forth. Next, we will introduce to IoT authentication with respect to device-to-device authentication and user-to-device authentication. In device authentication of IoT, throughout its development, from the earlier reliance on radio frequency identification to the application device fingerprint such as behavioral fingerprint among the periods, the research on machine-to-machine communication, and the mechanism involving physical unclonable function are the most attractive to us. Machine-to-machine communication is one of the most efficient mechanisms to transmit data between terminals. It could highly automate industrial process with guaranteed data security. According to the figure of process, the left figure presents the phase of registration, and the sensor need to construct a connection with the server in a secure channel. In addition, the right figure is the main stage of the authentication process, which includes computing the message by hash function and XOR operation. Exchange session key to check whether the message is valid or not. The feasible unclonable function is also an efficient authentication method for IoT devices. It can ensure the uniqueness of the device, improve security of mutual authentication between devices and servers, and reduce the amount of data transmitted during authentication process. The left figure shows the setup of a secure channel in order to store keys, which could help to check the validity of messages in authentication. What's more, the right figure illustrates the authentication process by establishing a secure session key which contains the step of request for interaction, server response, server authentication, and the device authentication.
Now we come to the area of user authentication in IoT. As we mentioned earlier, limitations in computational power force researchers to develop and design lightweight encryption algorithms such as ECC. Based on the requirement, 2 tasks are developed. The first one is how to find appropriate user identity. In the early studies, password and smart card were used as user identity. However, device stolen or impersonation attacks push us to use user biometric information or behavior pattern as user identity. The second task is based on proposed user identity to develop an authentication scheme that satisfies mutual authentication. In a recent proposed biometric-based user authentication scheme, there are 3 phases. In the registration phase, both user and device will register at the gateway. User use masked password and biometric information to request registration parameter from the gateway. Because biometric information such as fingerprint or face may slightly change by time, an important type of hash function is used to mask biometric information, which is called perceptual hashing. In login phase, the user will directly send a request to the device node and let the device start the authentication phase in the gateway node. Gateway will receive UNI and AJ and recover them using registration parameters. If the recovered value equals received value, mutual authentication is done at the gateway node. User use returned VI to authenticate the gateway. In this authentication scheme, timestamps will be examined to prevent replay attacks. Only hash functions and XOR operations are used in this scheme to guarantee the efficiency.
In device authentication, the machine-to-machine communication has been considered not able to resist the attack from masquerade as a terminal, and the physical unclonable function does not countermeasure against machine learning attacks.
In user authentication, although biometric information can make the scheme more robust to attacks, the biometric feature extraction is expensive and the accuracy is still an issue. In the proposed scheme, the author assumes all devices are already registered at the gateway. However, in practice, the device-to-gateway share key in the device registration phase is not securely defined. The reason we separately present the device and user authentication is currently there is not a unified scheme that can solve both device and user authentication. More researches need to be done to develop a unified protocol for IoT authentication. Thank you very much.